Today we are going to take a deep dive into CodeReady Containers deployment on Linux. Hey, what's up everybody? Welcome to my channel. My name is Aleš Nosek and I am the software practitioner located in San Diego, California, helping you navigate the world of Kubernetes. Recently, I wrote a blog about deployment of CodeReady Containers on Linux. If you haven't seen this blog, I will include a link down below. In this video, I'm going to walk you through the process. Let's take a look how the deployment of CodeReady Containers on Linux looks like. To illustrate the situation, I have drawn this diagram here, and you can see that CodeReady Containers will deploy a single virtual machine, and this virtual machine will run OpenShift cluster. Now, this cluster is actually a single node cluster where that one node plays the role of the master and the worker node at the same time. The CodeReady Containers OpenShift instance comes with a ingress router which is directly accessible from your Linux host. Also, there is a public route already pre-configured which you can use to access the integrated image registry. So if you have images which you are storing outside of OpenShift cluster, you can use this route to push them into the integrated registry before you launch them. The last thing I wanted to mention about the OpenShift configuration here is that CRC will come also with a pre-configured set of persistent volumes. That will allow you to create persistent volume claims, and both read-write once as well as read-write many scenarios are supported. So if you have existing applications and they are using PVCs, you will be able to deploy them on CodeReady Containers OpenShift. So how does CodeReady Containers create this virtual machine? On Linux, CodeReady Containers are going to leverage the library called libvirt, as well as the virtualization technology KVM. Now, before you can install CodeReady Containers on Linux, you have to have the libvirt and KVM already pre-configured. That means that you need to have appropriate privileges, it means sudo privileges, to be able to deploy virtual machines. I will be demonstrating this in the later part of the video. However, CodeReady Containers will create a libvirt network for you. Then it will also create a storage pool where it will store the image for the virtual machine to be created. And after that, CodeReady Containers is going to create a virtual machine in libvirt and launch it. Let's now discuss the left side of the diagram. The left side of this deployment diagram is showing how CodeReady Containers will configure your DNS resolution on the Linux host, so that you are able to access the API server as well as the wildcard route, it means your applications, in the OpenShift cluster. Now, you will be able to access them using the normal usual DNS names, for example, api-crc.testing, as well as apps-crc.testing. So how does CodeReady Containers achieve the DNS configuration? CodeReady Containers assumes that you have a network manager installed on your Linux box. So it is a requirement, if you want to install CodeReady Containers, that you have a working network manager configuration. The particular DNS resolution configuration will depend on if you are using systemd resolved to manage DNS resolution or if you are not. In the diagram, I am showing the situation where you are not using the systemd resolved to manage DNS. CodeReady Containers is going to configure the network manager to create a DNS forwarder. The network manager will also change the etc-resolve-conf on the machine to use this forwarder as the default DNS server on that Linux box. That means that from now on, all DNS queries will be sent to the DNS forwarder. The DNS server running inside of the CodeReady Containers virtual machine is used by the Linux host, as we've just described, but also it is used by the virtual machine itself for resolving the OpenShift related endpoints. So let's now walk through an example scenario where the OC client is trying to access the API server running in the CodeReady Containers virtual machine. So the OC client is going to contact the API server whose host name is api.crc.testing. The port would be 6443. So in order to resolve the host name to the IP address, the OC client is first going to consult the etc/resolve-conf, where they will learn that the address of the DNS server to ask for resolution is actually the localhost address. So from there, the OC client is going to send the DNS query to the DNS server running on the local host. And this DNS server is actually the DNS forwarder, which was created before. Now, this DNS forwarder will look at the query, will find out that we are querying one of the OpenShift endpoints here. So in that case, the DNS forwarder is going to forward this query to the DNS server, which is running inside of the CodeReady Containers virtual machine. Now, the DNS server within the virtual machine has configuration which resolves this name to the IP address, which is the IP address of the virtual machine itself. It means that the DNS server will respond that the IP address is 192.168.130.11. So this IP address is forwarded back by the forwarder back to the client, and now the client is going to connect to the API server by opening a TCP connection to the OpenShift virtual machine, and there on the port 6443, that's where the API server is reachable. So now that we know how the CodeReady Containers deployment looks like, let's dive right in. Before you can install CodeReady Containers, you will need to download the CodeReady Containers distribution archive and also a so-called pull secret. This pull secret allows you access to protected Red Hat hosted image registries. You can obtain your pull secret from, for example, the developers redhat.com site, where you can create a cost-free account and register yourself. After that, you can download your pull secret. So I downloaded the CodeReady Containers distribution archive, and also I untarred it already. If I go in, then you can see the content of the archive. There is the CRC binary as well as PDF documentation. Now you can tell that the CRC binary is pretty large. It actually is 2.6 gigabyte large binary. So what is inside of that binary? Let's take a look. This diagram is showing the internal structure of the CodeReady Containers binary. You can see that on the left side, the binary includes the CRC executable. So that is the executable code that we are running when working with CRC. In addition to that though, there is also another executable called admin helper Linux. This executable is used by CRC to edit the etc hosts file. Then in the binary we can also find a CRC driver libvirt. Remember that this particular binary is supposed to install CRC on Linux, and that's why the driver, which is bundled within the binary, is the libvirt driver. This driver is a daemon, a small daemon, which the CRC will start during the deployment process, and this daemon is abstracting the underlying details of the virtualization platform away from the CRC core. In our case, this driver will be called by CRC in order to create a storage pool as well as to create the virtual machine using libvirt. The last part of the CodeReady Containers binary is the so-called CRC bundle. You can see that the bundle is based on a particular OpenShift version, which the CodeReady Containers are based on. In our case, it is the version 4.6.9. This bundle includes the metadata in a JSON format, and then the largest part, which is the CRC virtual machine image in the QCOW2 format. So this image is almost 2.6 gigabytes large, and that's the image where the OpenShift is pre-installed on that image, and it's the OneNote pre-installed OpenShift. The next part in the CRC bundle is a private SSH key. This key is used by CRC during the initialization, during the initial deployment, in order to be able to SSH into the virtual machine and do additional configurations. This key, after the initial start, is removed from the virtual machine so that it cannot be used anymore to log into or to SSH to the virtual machine. Instead, CRC will generate a random public-private key pair, which can then be used for SSHing into the machine further on. Then in the bundle, you can also find the kubeadmin password, so that's the password to log in into OpenShift, kubeconfig file to again log in into OpenShift using client certificate authentication, and the last part here is the OC client. The OC client bundle here is the exact same version as the OpenShift server. Back to the console. Before I will run the CRC setup command to start the CRC deployment, I would like to show you the configuration which I created ahead of time. So CRC stores its configuration in the home directory crc.json, and you can see some of the configuration options which I like to use. So first, I set the consent telemetry in my case to yes, but the purpose to set it like already ahead of time is that the CRC will be not asking interactively what is your choice. So instead it will just go ahead and take the configuration from here. Next, I like to leverage the resources which are available on my desktop machine. So I bump the number of CPUs which CRC will use up to 10. Also, I like to enlarge the disk size which CRC will provision. From the default value of 31 gigabytes, I prefer the 120 gigabytes, which is the default size when you are installing the OCP, the OpenShift Container Platform. Next, I also give CRC enough memory, in my case 46 gigabytes, and then I also tell CRC where my pull secret file is sitting, so that CRC doesn't need to ask me and prompt me for the pull secret file. So with that, we can now run the CRC setup command and give it the sudo access. The main part of that setup is to extract all those parts of the CRC binary, as well as the CRC will create the network definition in libvirt. I will pause the video here and we will take a look at the outcome. So after a minute or so, let's take a look at what the CRC setup command did. From the console output, we can take a look and see that the CRC setup command extracted the parts which were in the binary. So there is the admin helper Linux utility was extracted. Also the bundle, extracting bundle is now extracted and decompressed. Next, we also extracted the CRC driver libvirt. On top of that, the CRC setup command also takes care of the configuration of the network. That means that we are checking that we do have a network manager running on the machine, and then we create that network manager configuration, which, if you remember from the deployment diagram, will instruct the network manager to create that DNS forwarder. And then CRC will also reach out to libvirt to define the network for the CRC virtual machine, which we are going to create in the next step. So the next step is to start the crc start command, and the outcome of this command will be a running OpenShift single node in the virtual machine on the Linux host. I'm going to pause the video now because it will take a while. Alright, after several minutes the crc start command is complete. I will scroll up a little bit so that we can review the output of this command. I will take it from the top. So first, the crc is running several pre-checks to ensure that the environment is still healthy, including checking the networking is correctly configured. After that, crc verifies the bundle. I'm not sure how that verification exactly looks like. I assume maybe a checksum check, but I don't know that. After that, crc is defining the virtual machine in libvirt, and it will start the virtual machine. As soon as the virtual machine is finished booting, crc will SSH into this virtual machine using the bootstrap SSH key, and immediately after that crc is going to generate a new SSH key pair which will replace the bootstrap one, and this new SSH key pair is configured to the authorized keys of the core user in the virtual machine. So from now on, that new SSH key pair is used to SSH into the virtual machine as user core. Next step is copying of the kubeconfig file to the instance directory on the local machine. This kubeconfig file is going to be used by crc to talk to the OpenShift APIs. In the next step, crc is starting the network time synchronization in the virtual machine. I assume that is the CodeReady service, and it was possibly disabled while generating the crc image. After that, we check that the DNS resolution works as expected, and we will upload the user's pool secret to the instance disk. Next, we will start the kubelet service, and we will verify the validity of the client and serving certificates of the kubelet. Now, in order for the kubelet to be able to connect to the server, to the Kubernetes server APIs, it has to have a valid client certificate. This client certificate is issued with the expiration time of, I think, 30 days, and so needs to be rotated within that period. So because this OpenShift cluster was actually not running since the image, the virtual machine image was created, then this certificate already expired. And so in that case, kubelet is going to generate a CSR request with a new certificate and send it to the Kubernetes API server. After the CSR is approved, the kubelet will receive a signed, correct, and fresh certificate, and from now on it can talk and authenticate to the Kubernetes APIs. Now, in order to sign the certificate, this operation has to be approved, and that's where crc actually watches or approves any CSR requests during the startup process. So it will automatically approve CSRs so that the kubelet can connect always to the Kubernetes API server. In the next step, we are adding the user's pool secret to the OpenShift cluster so that OpenShift itself can use that pool secret to talk to the protected image registries. After that, we are updating the cluster ID. I think this update happens when the cluster ID is empty and a new random cluster ID is generated at this time. I'm not sure. I would not say that the cluster ID was empty in our case. And then we are just waiting for the OpenShift to come up. And at the end, when the OpenShift is up and running, crc prints out some convenient instructions for the user how to connect to the OpenShift. So user can either use the developer account, which is less privileges, or the user can use the kubeadmin administrative account to talk to OpenShift. Congratulations, you now have OpenShift single node cluster running on your Linux machine. So what did we learn today? In today's session, we took a deep dive into CodeReady Containers deployment. We reviewed the deployment diagram. We looked at the internal structure of the CRC binary, and we configured CRC before we set it up and started the CRC cluster. I hope you enjoyed today's video. Please feel free to leave your questions or comments down below. If you found the video helpful, please consider subscribing so that you are notified whenever I release a new video. Until next time.